Good afternoon, everyone. Thank you for attending this workshop on securing open source dependencies to detect weak links and weak links in your software supply chain and address any or mitigate any software supply chain attacks. I'm Ashish. I hold a PhD in cybersecurity and computer science operating systems from Georgia Tech. And this is where you can reach me. I am a security researcher at Oscillate, and we are building tools to mitigate software supply chain attacks. Open source software, as you know, is eating the world. It's the de facto standard way of building digital apps and services. Modern open source software is actually distributed and consumed as packages on popular package managers such as PyPy, NPM, RubyGems. There are millions of packages available. For example, PyPy hosts over 300, maybe 400,000 now, and receive millions of downloads every week. So anybody can publish their packages on these package managers. They provide command line tool for frictionless publishing of your package. Any individual developer, organization, group of developers can use this tool to easily publish their package. However, there's little to no security vetting. What does that mean? That means that all the software that we use today on our devices, they are written by unknown volunteers that we blindly trust. And bad actors actually exploit exactly this trust. This is evident from past several incidents. According to a recent study, software supply chain attacks tripled in 2021 alone. And these attacks have been carried out on all ecosystems, NPM, RubyGems, PyPy. No ecosystem has been spared. So what are these supply chain attacks? Bad actors actually target less secure packages or weak links in your software supply chain to propagate malware. Unlike vulnerabilities, the malware that is propagated is intentionally malicious. It's not a programmatic bug. It's not an accidental bug in the code. It's very much something that they want to propagate. They want to basically, for example, steal your SSH keys. It's very much intentional. An example would be, backdoor, like I mentioned, that steal your SSH keys. And such attacks pose direct and serious threats because the same malware can be adopted by thousands of apps and can reach on millions of devices and compromise users' privacy and security. So let's understand various techniques and attack vectors that are used. So I mentioned that malware is not propagated by leaving an accidental programming bug, unlike log4j or Heartbleed, right? So what are different attack vectors that these bad actors use? So one of the attack vectors or technique is typo squatting. So what these malicious actors do is they publish a package with malware and they impersonate popular packages, existing popular packages. And we have provided example here. So for example, Colorama is a typo squatted package and it impersonates a popular package, Colorama, and basically it is misspelling. And these bad actors rely on developers' inexperience or typo made during installation to propagate malware. So, for example, if a name typo during package installation can end up malware, it can install backdoor on your machine or your CI/CD pipeline. Let's look at one of the examples of typo squatted packages in detail. In this case, the package is MITM proxy 2. It was a malicious package that was published on PyPy. It impersonates a popular package called MITM proxy. It has 2 in the end. And what these bad actors are doing here is they are provided exactly the same project description and other stats. For example, repo on GitHub, everything is the same. It's just that the code is different. And what the code does is basically it removes all the safeguards. So what can happen now is that anyone on the same network can execute malicious code on your machine with a single HTTP request. Social engineering is another technique that's been used by bad actors to propagate malware. And NPM package event stream is a good example. Here, attacker first gained trust by contributing useful code to add new features. So in this case, in event stream case, what happened was there was a genuine contributor who provided useful features, code contributions, and he gained trust, he gained contributor privileges, and then later on he changed the dependency and pushed some malicious code. And this is a very good example of how serious this threat could be, because this package has millions of downloads every week. Dependency confusion is another attack vector that they use. What happens is enterprises typically rely on internal mirror of NPM or PyPy, because if NPM or PyPy goes down, their CI/CD systems will break. So they mirror everything internally, and they may have their own packages published to their internal mirror. And bad actors basically can go through the GitHub repos or public repos and find out your dependencies by going through project manifest files. And they can publish a package with the same name as one of your internal packages, but with a higher version. So the default behavior of the Artifactory or the internal mirror that is maintained by enterprises is that it always prefers the highest version, the latest and greatest. So if an attacker happens to know name of the package that you're using internally, they'll publish a package with the same name on public package managers, whether it's NPM, PyPy, or RubyGems, and your Artifactory will download this external package and not prefer the internal one, because the bad actor will use a very high version, 99.0 or something. Another technique that we have seen is account hijacking. A popular example is UA Parser JS, a JavaScript package on NPM with about 8 million weekly downloads. This package is used in apps and websites basically to discover the type of browser you're using, using the user agent data. So in this case, what happened was the attacker hijacked account of its maintainer and published malicious versions of this popular package. And one thing to note here is that there were no similar, so they published a new version which was malicious, but there was no version by that name on public source repo. Another technique that we have seen is code sabotaging. This was one of the recent examples. There was a protestware or a malicious package that was created to protest against the Ukraine-Russia war. And what happened was the developers abused their own code. They injected malware or code to check if you are in some geolocation, and if that flag is true, then it will do rm-rf on your current directory. So it may just wipe out your computer. So this shows how a disgruntled attacker can abuse their own package. So what are these malicious packages? What do they look like? So this is a case study. This is something that we found, and we reported to PyPy. This is a malicious package that uses risky APIs during installation. So as you can see, the setup.py file in case of this package executes code at runtime and spawns processes. Basically, it will download this download code from this URL, and it will download code from this URL, and it will spawn a process to execute this malicious payload. So the question is, how do we defend against these attacks? Well, security is a shared responsibility, so we all must do our part. For example, we can enable two-factor authentication. That will make it difficult for attackers to hijack your account. Name scoping will help against typo squatting. Package signing can help against dependency confusion if you are checking the integrity. However, these measures fall short. For example, if a maintainer or disgruntled maintainer decides to sabotage their own package, then code signing will not help. Two-factor authentication will not help. Similarly, social engineering, these measures will not help. This is a figure that's been taken from salsa.dev, a supply chain security framework from Google. As you can see from this figure, an attacker can basically target your software development workflow at multiple steps, and no single tool can protect you against all these attacks. That's why security defense is always layered. So what do you do in this case? So as you can see, one of these steps would be use of a compromised package, right? So if you're using a compromised package, no tool framework can basically protect you. So developers, security engineers, DevSecOps people, they must all adopt a zero trust approach and thoroughly vet a package's behavior before you adopt any open source dependency. However, this is easier said than done. Manual vetting can be infeasible because packages may have hundreds of transitive dependencies, direct and transit indirect. So for example, in this slide, you'll see PyTorch package dependencies. And this graph, by the way, only shows dependencies that are at or transitive dependencies that are at a distance of 2 or less. So there are many more. So you can see the PyTorch package includes several dependencies, and manual vetting would be tedious and error prone. So definitely you would think automation is the way to go, and you could use some tools. However, existing open source vulnerability scanners, they assume that open source is all benign, it's all trusted. For example, in this slide, this is from Sneak. It's called Sneak Advisor. This is an example malicious package maybe published by a security researcher on PyPy. And Sneak fails to identify that this is a malicious package or there's some security vulnerabilities in it. What about stats from, let's say, GitHub? Can you use, or PyPy or NPM? Can you use downloads? Can you use stars as proxy to infer stability or maturity of a package? It turns out, no, you cannot rely on them because those are not robust. Those are actually attacker control. An attacker bot can manipulate downloads, can manipulate number of stars and forks, and more importantly, you can see that there is no provenance information when a package is published. So anybody can publish a package and point the package repo to Kubernetes, let's say, right, just to gain over 10,000 stars. So this approach is called star jacking. We have seen this done by many packages, many malicious packages. So you obviously cannot rely on stars or downloads or forks. That's why we built this tool called Package. It's for automating vetting. It's available on GitHub. And what it does is basically it will check for over 30 risky code and metadata attributes. It's based on academic research. It started at Georgia Tech. And these risky code and metadata attributes were basically derived by studying past documented over 600 or 650 malicious packages. And it will check for attributes such as package is old or abandoned, because abandoned old packages do not receive security fixes, and they may still have vulnerabilities like Heartbleed or Log4j. Is the maintainer email valid for two-factor authentication? Because if it's invalid or it's missing, then definitely two-factor authentication is not enabled, and the account can be hijacked. Does the package read file or send data over the network? Maybe the package is trying to share telemetry information back with the author, and that may make your enterprise or your company non-GDPR. So checking for that is good. Is this GitHub or a source repo available on publicly on let's say GitHub? So like I mentioned in one of those case studies, we found that there was no malicious version on source repo. So checking for missing versions that are available publicly, in source form or missing repo is definitely a good indicator of something suspicious. And we have created a command line tool, also a GitHub plugin, to help developers, security engineers, and DevSecOps people to quickly detect risky packages, and hopefully it'll reduce heavy manual vetting to a couple of code glances just to verify that everything is okay. And security tools are known for false positives and high noise, and we understand that. So we have created this tool to be that can be customized to your threat model. And I'll get to it. And basically, it reduces your alert fatigue. So how does it work? So like I mentioned, it checks for risky attributes, metadata as well as code. So to analyze code, it uses static analysis and dynamic analysis. When it comes to code, malware has only one option to access any sensitive resource. For example, file or send something over the network. They need to use some APIs that are provided by language runtime, for example, JavaScript, Python, or OS, the operating system. So we check for those APIs. For example, if the package is using open read write APIs, then we know that it's accessing file system. And the idea here is to generate or to show permissions needed by the package, just like permissions are displayed on mobile apps. If a package uses network APIs, then it needs network capabilities. And if it's trying to generate something on the fly, let's say it's trying to download some payload from some remote server and then execute that payload, then it will need both network as well as code generation functionality, and we'll capture that. If they are trying to hide something by obfuscating, they'll use let's say base 64 encoding. That's again an API, and we'll detect that. So there is no way they can not use this API and be still malicious. Yes. So if the standard library comes from a trusted source, then like libc, I don't think we need to. But if it's relying on any other dependency, for example, when you write Python code, you rely on requests. Now request internally may be using some low-level API, and your package is using request API. So in this case, for the high-level package, it will not report anything, but for the dependency, it will report. So if you go down to the dependency level, it will report everything. Excuse me. And it will check for a bunch of metadata attributes as well. For example, we saw validation of maintainer email, which like if it's invalid, suggests lack of two-factor authentication, and which means that anybody can hijack their account. Old or abandoned packages that don't receive security fixes. Absence of a public source code repository for code verification. And it can also generate some metadata for typo squatting detection based on name similarity. So let's look at the repo in the demo. Is it visible? Okay, cool. So this is the repo. It's hosted on GitHub, and you can see that it can basically stop attacks like SolarWinds, ESLint, PyTorch. PyTorch was a recent incident that happened because of dependency confusion. And so it can detect, like you can see, it can detect malicious, vulnerable, typo squatting, other risky packages. And started as an academic project, and it's funded by various government grants. You can see a quick screenshot of how it works, but we'll do a live demo of this. And you can get started by using a Docker image, maybe a GitHub action or a PyPy package. uses static and dynamic code analysis and sandboxing. You can customize to turn off alerts. All right, let me show you the demo before we get deep into this repo and code. Okay. Okay, for some reason I'm not able to, so let me just mirror my screen. Okay, so this is the repo. You basically do a git clone and download this repo. This is the source code, and it also supports Docker. So there's Docker container that has everything built in, all dependencies, and that's the recommended way of getting started. So let's say we want to see what it does. So just to help, and it'll do authentication, which is something that will be needed in future. But audit and sandboxing is what we are going to focus on. So audit is auditing of packages for malicious and risky attributes. And sandbox is for safe installation of packages. So let's say we want to audit. Let me try again. Okay, so in this case, audit would accept multiple packages with P, or you can specify your dependency file with F, and it'll try to audit that. And you can enable dynamic tracing by specifying a T option, which means it will install the package and also get installation time analysis results. So let's say we do Docker, we use Docker, and we use this package latest image, and we audit. And this time we are just auditing a individual package. -P is for package. PyPy is the name of the package manager, and BS4 is the package name. So BS4 is a beautiful soup 4 package. And let's just audit this package, and we'll see what it does. All right, still visible? Okay, so it's going to first get the package metadata, VS4 package metadata from PyPy. So it found this version. Right, there's only one version. That itself is an indication of something that's risky or could be risky. And from the description, you can see it's a dummy package for beautiful soup. There are only 2 versions released, and that could be a risk. If it's not a risk for you, you can customize it, and I'll get to it how. It's checking for yanked releases. Sometimes, if a security issue or a malware is found within a package, then the admins of package manager will yank that release, and working with a package with too many yanked releases means either there's something wrong, maybe the account was hijacked, or so it's something that you should look at. So it's going to highlight, the tool is going to highlight that. So in this case, no versions were yanked. Checking this version is 2,605 days old, which is again risky. Checking release time gap. There's only 1 day since last release, so it's going to dump number of days it has been since the prior version. So there has only been 1 day, so which is good. The reason we check for this is because suddenly, in case of malicious packages, what we have seen is suddenly there'll be a software development activity after a long time, which could indicate that somebody got their hands on a popular package, and they are trying to inject something. So checking the number of days has been since prior release, it's a good indicator. Again, all these attributes are based on a study of past, over 600, 650 malware samples. It's going to check for author name and email domain validity for this. So in this case, it's valid. Then it's going to check for the documentation. In this case, it's 325 bytes. It's not nothing. Checking for homepage. So homepage is reachable, which is good. Downloads. This is a very popular package. 3.3 million weekly downloads. Then there are a bunch of checks that we'll add in the near future. It's going to check for repo, and this is the risk because no source repo is found. Also, if you look at binaries in this, there were two binaries. And finally, package tool detected that this is a dummy or troll package. Because analyzing code, it found no permissions found, no, just 0 functions, no functions found, right? And just 89 lines of code. No dependencies were found. And so you can see that a package with 0 functions has 3.3 million weekly downloads. Why is that? So it turns out that this is a dummy package for Beautiful Soup. So Beautiful Soup is a package to parse HTML, and the package name, the original package name is Beautiful Soup. It's just that when you import the package, in the code you write import BS4. So a naive developer always assumes that BS4 is the package name. So they are doing pip install BS4. And that is why we see so many downloads. So this is a proactive step taken by the developers of BS4 to register a dummy package, BS4. Right, and just to mention that this is not the package that you're looking for, right? It's just a dummy package. So this should give you a good idea of how this tool can help you. It can basically alert you if the package is dummy, empty, or troll package. If there are any binaries included in the package, if source code repo is found or not, if the version is too old, what permissions are needed, and what the release history of a package. Do you have any favorite package that you want to audit at this point? From NPM or PyPy or RubyGems? Okay. I can try Express. Let me clear the screen and try Express from NPM. All right. So it does the same thing. It fetched metadata. It found the latest version. The email domain validity is good for the maintainer. There's README present. No versions are yanked. Good, looks like a good package because there's been 270 versions. Very good number of downloads. So it says insecure web page. Maybe it's trying to redirect to some other web page. Maybe that's why. So you need to, if this is a risk for you, you can take a deeper look. There are 31 dependencies, which may be risky for some people. So it just points out, and you can take a deeper look. And it needs one permission, decode. So it's trying to decode the code, maybe base 64 decoding. And there are 16 files in the package. 12 of them are JavaScript files, 118 functions, and 8K line of code. And there were no binaries found, which is good. The repo was also found with forks and stars, and its original repo is not forked. Sometimes what happens is bad actors would fork a popular repo and inject malware and point to that. So checking that the repo is original, not forked, is good. And then you can see number of contributors and commits. And more importantly, you can compare. You can check package description here and the repo description here. Yes.
Couple questions. One, could you do NumPy, just because it's one I'm familiar with?
Okay.
And then can you see in that JSON report that it puts out, is all the data that's kind of the results that are used to create pass fail, is that all available in that JSON report?
Yes.
Okay.
So yes, thank you for pointing that out. So there's a report that it generates in the end, and it's a JSON file, and let's look at it. So it's going to dump all metadata and all analysis data. So for example, it just dumps some metadata that it receives from NPM about contributors, versions, releases, everything. And then dependencies, right? And then finally, you can see the analysis here. So it'll print out downloads, it'll dump repo data here, it'll dump dependencies and permissions. So if a permission is risky, for example, in this case, it decodes, reads hidden code. So you can go here at this line number, and you can try to read and see what it does. So basically what it's doing is it's narrowing down your manual vetting to a couple of code glances. And it'll dump the composition data here, number of files, functions, everything. And then finally the risk that it found. We'll get to NumPy in a second. Let me just show you how to customize this. So there is a file called package.yml. If you open that, you can see that audit alerts are categorized into 4 classes. Malicious is something that is known malicious, typo squatting or crypto miner. Suspicious is something that we have identified as, for example, inconsistent with source repo, overwriting system binaries, risky API sequence. Vulnerable is intuitive, it's just containing CVs. And undesirable, there are lots of attributes that could be undesirable for a lot of people. That's why it's customizable. So for example, if fewer downloads, so the threshold right now is 1,000. But if it doesn't matter for you, you can just disable that, just change that true to false. Insufficient README, same, you can just change that true to false, and it will not send you that alert. Yes?
Is it that if any one of those are set, you get a risky?
Yeah.
Okay. I wasn't sure if it was like ranked or if there was some weighting to it. Or...
Yes. So it's going to. So if you look at the previous run, there are 3 risks: 1, 2, and 3. Yet it says only 2 risks apply to you. So according to your configuration, only 2 risks apply to you. And if you look at the final report and you go in the end, so these are the 2 risks that you have enabled in your configuration. Yes? Yes, yeah, thank you again for that question. So it gives me an opportunity to mention that we are using OSV database from Google for vulnerabilities. So it just uses OSV APIs to query. Okay, so yeah, so for audit, there are multiple risky attributes that you can look at and maybe customize and maybe enable, disable them, and change the threshold. For example, custom installation hook could be one, right? We found that a lot of malicious packages use installation hooks. So as soon as you install a package, they are going to execute some backdoor, some malicious code as part of that hook. So presence of custom installation hook is something that should be checked. All right. So let's see. We do NumPy. So here it says no source repos found. Maybe it was not mentioned in the metadata, or maybe there's a missing check somewhere. For example, the home page is numpy.org. Maybe the repo URL also points there, and it's not a GitHub repo or any Git repo, GitLab or GitHub. Maybe that's why it says. So, but you can go and take a deep look. And finally, so you can see there's only there are only 2 risks. So it needs 5 permissions. Perhaps it needs all those 5 permissions. So, but it still points out. So what you can do is you can go to this complete report. Okay, let me clear this. And it says in the end of the report, you'll see undesirable attributes, files and directories, reads files and directories, writes to files and directories, reads user inputs, communicates with external network. Perhaps it's supposed to do that. It's just that it's good to point out. And what you can do is you can go up, scroll up in the report, and you can look at these line numbers, file numbers, file names and line numbers to see what APIs they are using, and if it's okay to you, then you can basically ignore them. And we can further customize it to basically ignore certain APIs. So hopefully that shows you how this package tool can reduce your manual vetting time. All right, let me change this. All right, so we have a Docker image that we just demoed, and then there's a GitHub action that you can use. It's available on GitHub Marketplace. So if you go there, you can just use this. The latest version, I believe, is 11. So you can use that. Just to show how you can do that is, so this is an example repo that we have created. And this uses the GitHub action. So if you look at the recent run, maybe, so in this case, there were 7 risky dependencies, and deliberately we are using risky just to demo. And if you click, so the way it works is, if somebody submits you a PR, the action runs on that PR and then comments on the PR and points out any risky dependencies that are introduced. So if you click for details, you'll see what is being used, why it's risky, and then you can go and take a deeper look. For example, this one uses, this one has known vulnerabilities as well, and we are using OSV database for that. Yeah. All right. So we actually ran this tool on hundreds of thousands of PyPy packages, and we found a lot of malicious packages that we have reported. And in order to find more malicious packages, you have to continuously run this, but we don't. We just did it one time, and we found about 70 plus malware, just one-time scan, and we reported our findings. So what you can do is you can go to our website. So if you go to the GitHub repo, this is the website, package.dev. And this is a service that we are trying to create with free reports and everything, with different kinds of plugins. For example, to protect your mirrors, to protect your CI/CD pipeline, to protect your repos. So there's a playground, and you can look for sample malware here that we found. And this is the example that I presented in the PowerPoint. So in this case, wow, okay, maybe there's something missing. But in this case, this malicious package is trying to download something from this URL and then execute this. So, and you can look at other malware that we have found. You can also reach out to us, and we'll give you access to all the malicious packages that we found. Okay, that's it. So thank you so much. The code is hosted on GitHub. We are welcoming code contributions, big or small. And millions of packages are actually pre-vetted from our last run at package.dev. And this is actually funded by NSF grant. And you can send your questions to oss@oscillate.com. Thank you. Questions? Yes. Yes. So for that, I think if you specify. Okay, let me clear the screen. Just a second. All right. So we used -p, which means vetting individual packages, but you can use -f and specify your file. For example, requirement .txt, and basically it'll vet everything that's mentioned in there. So it'll go deep in the tree, and it'll generate a final report, just like the GitHub action. So the assumption is that your requirements.txt or package.json lists everything, but it will not go deep. Yeah. So as long as your file is complete, it'll just give you everything. So we support npm, PyPy, Python, and Ruby gems. Yeah. And we're adding support for Rust, but it'll take some time.
Are you looking at Go?
Go is something that so Go is different because it doesn't have any package manager, as far as I know. It's just GitHub repos. So the attack vectors are different. So that's why I think we'll consider that later. Yes.
Do you have plans to add support for the .NET's NuGet package manager?
Yes, that's something on our roadmap, but I think Rust would be prioritized just because it's it's important for the crypto ecosystem. And yeah. Maven, yeah, that's something that's on our roadmap. Yeah. Anything else? Okay. All right. Thank you so much again.